So here we are going to start with the vector product of two vectors. Scalar product, we read about scalar product, which is showing that it do not have any direction left after the product. Means the final value is a magnitude only without any kind of direction. But when we talk about the vector product or cross product, it shows us the direction also, that after doing that product, what is the final answer of it. So let's see, this is from your book, a page number. If anybody is having a book, they can see from it. If you are sitting like that, I cannot help it out. So let's start with it. We have discussed on the three-dimensional right-handed rectangular coordinate system. In this system, when the positive x-axis is rotated counterwise into the positive y-axis, a right-handed screw would advance in the direction of the positive z-axis. Let's see here, this is your x positive axis and this is your y positive axis. If I am turning this x-axis towards this y-axis and just keep on rotating and rotating and rotating, what is this? This is shown in the form of a screw, and this is going in the direction of positive z-axis. Why this is being shown over here, this topic and this right hand thumb rule? Because they just wanted to tell you that in which direction the final vector will be there. So this is the positive z axis, where when this x is moving towards the y, then what is the direction? So from the definition which Siddhi also told, the vector product of two non-zero vectors a and b denoted by a cross b are defined. A cross b, a vector cross b vector is equal to a vector modulus b vector modulus sine theta n cap. N cap, this is the n cap which will be perpendicular to both the vectors. दोनों ही वेक्टर से परपेंडिकुलर रहने वाली. And what about this theta? Theta is just the same as scalar product. It is between 0 to pi. And n vector is the unit vector perpendicular to both a and b, such that a, b and n form a right-handed system. Finally, this a vector, this b vector and n vector form that three-dimensional, that is x-axis, y-axis and z-axis. So this is being shown in this figure. So let us move down. What are the observations? We read the observation of the dot product also one class back. Now we'll be learning for the cross product. A vector cross B vector is a vector. Wherever in the scalar product it was written here a magnitude which is not having any direction. Now the second point, let A and B be two non-zero vectors, then A cross B is equal to 0 if and only if A and B are parallel to each other. Why it is so? See here, it is given here sine theta. And when theta is 0, then sine theta becomes 0. Theta 0 means these two vectors will have no angle between them, means they are parallel to each other. So it is shown here, if they are parallel to each other or collinear to each other, then only the cross product will be 0. And in case of scalar product, we were supposed to prove that the dot product is 0, then they are perpendicular. Third is when theta is equal to pi by 2. Theta is equal to pi by 2 means sine theta is equal to pi by 2 becomes sine pi by 2, and this is 1. So then the value of this cross product becomes the multiplication of these two modulus vectors, that is A vector and B vector. In view of these observations 2 and 3, as they are for mutually perpendicular, unit I, J and K we have. What is going to be there? When I is multiplied with I, J is multiplied with cross product with J, and K vector with K vector a cross product, then we are going to get a 0. This is the conclusion we had drawn from this point 2. Means these are with themselves only, means they are parallel to each other or they are collinear, then their cross product is 0. And what about when I is with J, then what is the answer? See this circular law goes with it. This is I, this is J, this is K, and the directions are given in this direction. If I is with J, then the answer becomes K. If J is cross producted with k, then the answer becomes I. And when k is with I, we get j. And what about if we write the direction differently? Means in the other side direction if we put, then what is going to get? Then we will be having a minus sign
Negative.
over here. Yeah, I cross j will become minus k, j cross k will become minus I, and k cross I will become minus j. In terms of angle, sometimes they will be asking us find the angle between these two vectors. So the angle between two vectors will be given with a cross b upon modulus of a into modulus of b. These are the observation. Few more are there. Sixth is, it is always true that the vector product is not commutative. But in the scalar product we already know that it was proved that that was commutative, because we were just multiplying the coefficient of I, j and k with the coefficient of I, j and k with the of the other vector. So that was commutative. Now here it is, this is not commutative. A cross b will be equal to minus b vector cross a vector. See here, they had told us indeed A cross B is equal to this formula we had already done, where A, B and N form a right-handed system. But that is, a theta is traversed from A to B. This is valid, this formula is only valid when theta is moving from A to B. That only I told in the beginning, from x-axis to y-axis it is moving. Then the final direction is this n cap. But what happened if the theta is traversing from B to A? Because here it is showing B cross A. Now the theta we will be calculating from B to A. So this angle, this n cap changes and it goes downwards. This is becoming n1 cap. Right? They had given it here, where B, A, N1 form a right-handed system, that is theta is traversed from B to A. तो यहाँ पर इसकी वैल्यू ऐसे हो जाती है. अब यहाँ देखिए N is towards the upward and N1 is towards the downward. That is why a minus sign is being introduced over here. Otherwise, all the things are just the same. Thus, if we assume A vector and B vector to live in the plane of the plane of the paper, then N cap and N1 cap both will be perpendicular to the plane of the paper, but n cap being directed above the paper while n1 cap directed below the paper. So n1 cap is equal to minus n cap. Due to this, they can make a question from this also, a 1 marker or a 2 marker question, that why this vector product is not commutative. So you should know what is the reason behind it. So when here it is projected from A to B, here it is moving from B to A. That is why the final vector also, the direction is changed. And since the direction is changed, that is the reason that these vector product is not commutative. Let's see the other things. In view of the observation 4 and 6, what were the observation 4 and 6? Let's see here. These were the observation. I had shown you 5 and this was the 6th one. We have J cross I, वही जो बताया था कि अगर direction change हो जाती है, then a minus sign is introduced. J cross I becomes minus K cross J becomes minus I, and I cross K becomes minus J. What happens if A and B represent the adjacent sides of a triangle, then its area is given by, the question comes from here also, a 1 marker or 2 marker question easily can be made from here. If A and B represent the adjacent sides of a triangle, see this A triangle and B triangle, B vector is given with the sides of this triangle. And we have to find this area. We will find half of A vector cross B vector. बस हम इससे निकालेंगे. This is how you know how to find it out using the determinants. And we can get the answer. And in case we have to find the area of a parallelogram, and the two sides are given with A vector and B vector, just a normal cross product means finding out the determinant value of this only, and that will be the answer. Let's see, अभी तक भी लोग आ रहे हैं. And moving to this property, this is the property, distributivity of vector product over addition. हमने देखा कि कम्यूटेटिव तो नहीं है, व्हाट अबाउट डिस्ट्रीब्यूटिव? सो लेट अस सी फॉर द डिस्ट्रीब्यूटिव प्रॉपर्टी A cross B plus C. A cross B plus A cross C. We should know about this. You can say it's a kind of property which can be used whenever it is needed according to the question. And if it is a scalar number, lambda is being multiplied with A cross A vector cross B vector, then what is the solution? Means lambda into A vector cross B vector, or A vector cross lambda into B vector. And this is a thing which Sayam was telling, that whenever we have to find the cross product of any two vectors, we have to just put it in the form of determinants I, J and K. Here it comes A1, A2, A3 means these the components, scalar components of one vector, and B1, B2, B3 the scalar components of the other vector. Just find the value in the form of determinant and you can get the answer. So this is the theoretical portion, totally theoretical portion, which we